guys, it's Mr. Walker here. Welcome to another math lesson with Mr. Walker. In this lesson we got a lot of cool stuff going on with fractions. We've been doing a lot of great work with fractions for a while. Some problem solving, finding common denominators, adding, subtracting, all sorts of good stuff. And today we're going to be doing some critical thinking about fractions. That's going to involve us drawing out some pictures and just really kind of thinking about what fractions are and what they mean. So for this one, you're definitely going to need your thinking caps for this one. So I'm going to grab mine here. I have my, this is my construction hat. I guess that's probably not going to do. Maybe I can wear this one today. This is my one I wear when I'm blocking out the alien rays trying to infiltrate my brain. So maybe not this one either. All right, so I don't have my thinking cap today. Hopefully you guys have one. Put it on because we're going to need it for this. You'll also need probably something to write on and something to write with. And we are going to be taking a look at some specific problems from the module. So if you have that printout with you with some of those problems there, you might want to take a look at that as well. So I'm going to go ahead and get my stuff set up. You guys get your stuff set up. Press pause, whatever you need to do, and then come back and we'll get going. All right, guys, so the first question that we're going to take a look at here, again, this is some of that critical thinking stuff here. We're going to be working with some ribbon throughout a lot of these different questions, and it's going to give us some information about it, and we're going to have to kind of draw in or sketch in the rest of it. All right. So this one, for example, says one ribbon, and the piece shown below is only 1/3 of the whole piece of ribbon that we're looking for. Complete the drawing to show the whole ribbon. All right. So they're giving us a piece, right? They're giving us a piece of it, but it's only 1/3 of the whole piece. So that means if that's only 1/3 of it, we're going to have to add on some other thirds to show the whole thing. So I have my piece of ribbon right here that they already gave us. That's 1/3 of it. I'm just going to go ahead and draw another third, roughly the same size. I'm not a perfect artist here, but you get the idea. So there's another third, and here is my final third. So I now have 1, 2, 3 thirds, which would be equal to one whole piece of the ribbon. Okay, easy enough. Nothing too terrible about that one. We just had to think of it in terms of, okay, I know that this is a third. I know that 3/3 make up one whole. They want us to show the whole ribbon. There we go. All right, cool. So let's move on from here. And we have one. This one's a little more to it here. Again, we have one ribbon. The piece shown below is 4/5 of the whole. 4/5 of the whole. Keep that in mind there. 4/5 of the whole. Complete the drawing to show the whole ribbon. So we need to show the whole ribbon. This is 4/5 of it. Think about that for a second. What do we know about fifths? How many fifths are there in one whole? Think about that. Right, 5/5. There's 5/5 in one whole. We have 4/5 here. So if I take this and I split it into 4 pieces, 1, 2, 3, 4, this essentially now becomes 1, 2, 3, 4 out of those 5 pieces, which would be a whole. So I need to add on one more piece. So now I have 1, 2, 3, 4, 5, 5/5, 5/5, which is the same as one whole. And like they said, this purple piece that they already had up here, that represented 4/5. 1, 2, 3, 4/5. 5/5 is one whole. This is our whole piece of ribbon. Okay, cool. Let's keep moving on. You guys are doing great. All right, now we need to represent 2 ribbons. 2 ribbons, ribbon A and B. 1/3 of A is equal to all of B. And we're going to draw a picture of the ribbons. 1/3 of A is equal to all of B. I want you guys to think about that for a second. Sketch something out, what you think this might look like, okay, with 1/3, and if it helps, we can even write it as that. 1/3 of A is equal to all of B. What are these ribbons going to look like? Think about that for a second. Pause it. Let me know what you get. We'll come back. We'll discuss it. Okay, so we know we're going to have 2 ribbons. We're going to have ribbon A, and we're going to have ribbon B. 1/3 of A is equal to all of B. So I'm going to start by drawing A. And I'm going to draw my ribbon A as thirds. So there's 1/3, 2/3, 3/3. So still in all, in total, this is all one whole of ribbon A. I just divided it into thirds. Why did I divide it into thirds? Because 1/3 of A is equal to all of B. So that means that ribbon B is going to be equal to 1 of the thirds of ribbon A. 1 of the thirds of ribbon A. Perfect, okay? So this is something that you want to be showing on yours. You want to have something similar to this, okay? You could have started it another way by drawing all of A. A is one whole. And then thought about, okay, well, 1/3 of A is equal to B, so I'm going to take my A, I'm going to split it into thirds, and then one of those thirds is going to be the same size as B. However you chose to set it up is up to you, but you want to get something similar to this when you're done. All right, cool. Moving right along here, we're going to take a look at this one. We have 3 ribbons this time. Ribbon C, D, and E. C is half the length. Half the length. I'm just going to sketch some notes up here while I'm thinking of it so I can make those comparisons. C is half the length of D, and E is twice as long as D. Twice as long as D. Draw a picture of the ribbons. Whew, 3 ribbons here. C, D, E. C is half the length of D. E is twice as long as D. Draw a picture. All right. I want you guys to think about this for a second. Sketch something out. Pause the video if you need to. Use what you know, what the information they give you. Try to sketch something out. Think critically. Put those thinking caps on if you need to. And just sketch some things out. Don't be afraid to draw the wrong thing. If it doesn't look right at the end, you can always go back over it and review it. Change it up. Make sure it makes sense to you. Give this a try, then we'll come back and talk about it. All right. Hopefully you guys had some time to draw out your ribbon here. What I'm going to do is I'm going to read through this one more time because it kind of gives me a good starting place if you pay attention to what they're giving you. So it says that C is half the length of D and E is twice as long as D. So to me, reading this, both E depends on D and C depends on D. They're both, the length of those ribbons are given in relation to ribbon D. So I'm going to start by drawing D first, or at least what I think that might look like. So we'll start here, and I'm just going to draw a ribbon here for D. I don't know what the length is. It doesn't give me that, but it just says that it gives us lengths of the other ones based on what we have. So I'm going to start here with D, and it says E is twice as long as D. So if I'm drawing my ribbon E, I know I'm going to have to draw it one time as big as D, and then this would be twice as long, right? I drew another one roughly the same size, right? Twice as long as D. All right. C is half the length. So if I take D and I split it in half, that's what size C is going to be. C is half the length of D. All right. So at first, this one might have been a little bit tricky to think about and be like, I don't know what to do. But if you really read it and pay attention to it, you don't really have to worry about drawing any of them any certain exact size. We don't have any exact numbers to go off of. But we know that C depends on D, and E depends on D, so we had to draw D in first, and then we could base everything else off of that. Okay? So hopefully that makes sense. Start to make some connections there. Since you're doing so awesome, and you still have your thinking caps on, let's try another one, right? All right, this one says half of Robert's piece of wire is equal to 2/3 of Maria's wire. The total length of their wires is 10 feet. How much longer is Robert's wire than Maria's? So the total length is 10. All right, total length is 10. So they're actually giving us like a number to work with in this one. Total length is 10. Half of Robert's piece is equal to 2/3 of Maria's wire. Okay, so we got a couple things going on here. So let's just start sketching some stuff out. All right, I'm going to put R here for Robert. I'm going to put an M for Maria. Half of Robert's piece of wire is equal to 2/3 of Maria's. So if I think about it this way, here's Robert's. And I know I'm going to need half of Robert's shown. So there's half. Half of Robert's, okay, is equal to 2/3 of Maria's. So if I have Maria's here, she's going to basically have 3 pieces, right? Hers is going to be in thirds. But 2 of those thirds, 1, 2, is going to have to line up with that half of Robert's. okay? Half of Robert's wire is equal to 2/3 of Maria's. So we have that there, all right? You with me so far? This is going okay? All right. So 2/3 of Maria's, we got that. The total length of their wires is 10 feet. So that means if I added up all of these lengths, whatever the lengths are here, it would be 10 feet. 10 feet. How much longer is Robert's wire than Maria's? So they want us to find this part. It's like missing piece right here. How much longer is Robert's wire than Maria's? Goodness gracious, we got a lot of stuff going on here, right? All right, I want you guys to just think about this diagram that we have mapped out here. How can we use this to help us figure out this missing length right here? How can we use it to help us figure that out? Take a second, pause the video if you need to, then we'll come back and we'll discuss it. All right, so my pieces aren't exactly lined up here, but we can kind of get the idea of what's going on. So if I'm going to come up here as well. Actually, I'm going to change my color up here, and I'm going to put some lines in here to kind of match up my thirds. Okay, and then this guy would be, not there. This guy would be right about here. Okay, so 2/3 is equal to a half, right, and a half. So all together here, if I'm counting up the pieces that I actually have, we have 1, 2, 3, 4, holy cow, 5, 6, 7. I have 7 pieces here, right? And then this like missing piece because they don't line up totally because his is longer than hers is. All right, so those 7 pieces make up 10 feet. So if I take that 10 and I divide it by 7, that will give me the length of each piece of ribbon, okay? Which would give us a decimal, and we can work that out if we need to. But basically, we can also just say that Robert's piece is 10/7 bigger. Robert's ribbon is 10/7 bigger. It's that one piece. Oops, sorry, I didn't mean to move that piece there. It's that one piece bigger, which is the same as 10/7. All of these, if all of these shapes were the same size here, okay? So 10/7, 10 divided by 7 would give us the measurement of each of these. And like I said, we could divide that and get the actual decimal, or we could just say that Robert's piece is 10/7 bigger. Robert's ribbon, as a total, is 10/7. This piece right here is 10/7 longer than Maria's, like that missing piece right there. Okay? Hopefully that makes sense. If it doesn't make complete sense, it's okay. We're just trying to get some conceptualizations going here about fractions and about ribbons. Okay? All right. Hang in there with me. We got one more. I know that thinking cap's probably getting a little itchy, making your head itch. That's okay. We're going to just try one more together, and then we'll be good to go. All right. This one says that half of Sarah's wire is equal to 2/5 of Daniel's. Chris, crazy Chris there, he has 3 times as much as Sarah. In all, their wire measures 6 feet. How long is Sarah's wire in feet? Man, got a lot of stuff going on here. We got Sarah, we got Daniel, we got Chris. We got them all hanging out. They have these different wires, trying to measure them. I don't know why. I guess it's measure wiring day, something like that. They got some stuff going on. So we got to map this out. I want you guys to take your time first, or take some time first, and try to map out what their wire lengths would look like, using boxes, using those tape diagrams, whatever you need. Map that out, and then we'll come back and take a look at it together, see what we got. All right, guys, so this one was a thinker, right? This one made my brain hurt just a tad, but I think we can map this out pretty well, right? So here's what I did. We had Sarah's wires equal to 2/5. Chris had 3 times as much as Sarah. So to me, Sarah is kind of like our starting point, right? She's the one that everybody else kind of revolves around. She must be like super awesome, right? So we have Sarah's wire equal to 2/5 of Daniel's. So I started by drawing Sarah's wire here, and I just drew a blue box, or blue rectangle, blue tape diagram, and it said that her half of her wire is equal to 2/5 of Daniel's. So I drew a blue line to split hers in half, and then I lined up Daniel's here. I knew that 2/5 of it was going to equal her half. So I just drew a rectangle for Daniel, and then I made sure that I split it into fifths, but that out of my fifths, my 2/5 and her half lined up. Kind of making equivalent fractions there in a sense, okay? So I did that. I also went ahead and split Sarah's as well in line with the other fifths of Daniels, because then we made some equivalent fractions, in a sense, or at least we can kind of visualize all of them and how they match up, right? From there it said that Chris had 3 times as much as Sarah. So I took Sarah's here and I just copied it 3 times. 1, 2, 3. Right? So now we have everybody's lines all drawn out, or their wires all drawn out, okay? And we do know that together, or in total, all of this measures 6 feet. And again, like I said, I had my Daniels, we had his fifths, Sarah, we had a half, but I went ahead and matched up the fifths as well. And then I copied that into Chris's too. So if I look all together at all of these pieces, we have 21 total pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 pieces. 21. And of those 21 pieces, altogether they equal 6 feet. So if I kind of reverse engineer that in a sense, and I take that 6 feet and I divide it by those 21 pieces, that means that each piece is going to be equal to, well, I could do that and get a really long decimal, or I could just say it would be equal to 6/21. 6/21. Sounds funny. But that information can help me with the last part, which is how long is Sarah's wire in feet? Well, each one of these boxes I said is 6/21, 6/21. So if I add those up, 6/21, if I add up 4 of those, I am going to get 24/21. 24/21, which is the same as 8/7. 8/7, okay? Because 24 divided by 3 is 8, 21 divided by 7. I'm sorry, 21 divided by 3 is 7. Holy cow. So this one hurt my brain, like I said. All right, again, this is a problem that you cannot necessarily do in your head. This one you're going to have to write out. You're going to have to draw those tape diagrams. You're going to have to think about these things visually and how they lay out. So it's totally okay. Even if you don't get it the first time and you got to rearrange and sketch stuff a different way, it's fine. Don't worry about it. That's what math is all about, trial and error, okay? So don't sweat it. But hopefully this helps. Hopefully this gets you guys going in the right direction. There's some more practice with some of these problems available in the module, so I would definitely take advantage of those, because these are ones that take a little bit of thinking. So if you need a thinking cap, you let me know. I can mail you some aluminum foil. You can stretch one out, make it work for you. But definitely wear it while you're doing these, because it's going to help. So thank you guys for working with me with fractions for today. Let me know if you need anything else, and we'll talk to you soon. Thanks.